Hello, welcome to lesson 14. This lesson is titled Outliers. Now, we have talked about extreme values in previous lessons. We looked at how it affected the measure of center and the measure of variability. Today, we're going to continue to look at those features as well, but we want to understand what makes something an outlier. How do we determine whether something is an outlier or not? And if it is an outlier, how do we determine whether we keep those outliers in our data set or whether we remove them? So in today's lesson, we're going to investigate outliers and how to deal with them. Your learning targets are to be able to say that you can find values that are outliers, investigate their source, and figure out what to do with them. Also, to be able to say that you can tell how an outlier will impact the mean, median, IQR, or standard deviation. So we have our warm-up. This one is titled Healthcare Spending. So they give you a histogram, per capita health spending by country, and they give you a box plot of the same data. And they want to know what is one thing you notice and what is one thing you wonder. Now, if you're in class, you can talk to those around you. If you're watching this outside of class, then you can simply take a moment, see what you notice and what you wonder, pause the video, take a moment or so to look at it, and then start the video back up. All right, so this says the histogram and box plot show the average amount of money in thousands of dollars spent on each person in the country, which is what we mean per capita. And this is for healthcare in 34 different countries. Number one says one value in the set is an outlier. Which one is it, and what is its approximate value? So to answer this, we want to look at the histogram. And our outlier would be this value down here. Okay, it's out here by itself. We notice it's much higher than where we would expect the mean or the median to be. So this is our outlier. And the value is somewhere between 9,000 on the low end to under 10,000. So that could be 9,999 and 99 cents. Okay, but it couldn't be 10,000 because that would start up a new bar on our histogram. Now, question 2, by one rule for deciding a value in an outlier, if it is more than 1.5 times the IQR greater than Q3, show on the box plot whether or not your value meets this definition of an outlier. So in order to find the IQR, remember that our IQR is our Q3 minus our Q1. It's how big the box is. So in this case, it's just below 5. So maybe we'll say 4.9. And it's just above 2. So maybe we'll say 2.1. So this means our IQR is 2.8. Now, the 1.5 times means we're going to take 2.8 times 1.5, and that is going to be approximately 4.2. So what we would want to do is take the IQR, which we said was 4.9, and we want to add this IQR plus 1 or times 1.5, which we said was 4.2. So that puts us at 9.1. So this may or may not be considered an outlier because it could be as small as 9,000 or it could be as big as just under 10,000. So this may or may not meet the definition of an outlier according to this. Okay. So now to synthesize this activity, it says values in a data set that are greatly different from the rest of the data are called outliers. The precise meaning of greatly different will be different for different situations. For example, a possible $4,000 difference in this graph does seem like a lot, but if the data represented the entire budgets of these countries in the billions or trillions of dollars, rather than spending on each member of the population for healthcare, it would not be a great difference. Using the IQR to determine outliers helps to adjust the difference to the variability of the bulk of the middle data. Using 1.5 times the IQR allows for some variability on the ends of the distribution to be considered usual. So when we do this, we can take 1.5 times the IQR and add it onto the end of Q3, and anything above that would be an outlier. We could also take 1.5 times the IQR, subtract it from Q1, and anything lower than that mark would be considered an outlier. Here they give an example of that. It is also possible for there to be values that are unusually low compared to the rest of the data set. Consider this box plot that displays Q1 minus 1.5 times IQR. So our Q1 is the left side. So if this is our Q1, we go 1.5 times. Now anything out here would be considered an outlier. And if we add 1.5 times IQR to our Q3, which is the right side of our box, now anything on the higher end past that would also be considered an outlier. So it says the minimum value for this data set should be considered an outlier. For the purposes of this unit, a value will be considered an outlier for a data set if it is greater than Q3 plus 1.5 times IQR, or if it is less than Q1 minus 1.5 times IQR. These formulas compare extreme values to the middle half of the data to determine if the value should be considered an outlier. So that is the measurement we are going to use. So now we'll move on to our first activity, which is called investigating outliers. So here they give us a data set used to create the histogram and box plots from the warm-up. So these are the actual values given. So now we can see that outlier we were looking at. We said if it was above 9.1, it would be considered an outlier. And it turns out the value is actually 9.8923. So according to our calculations, we would have considered this one an outlier. So now they want us to use technology to find the mean, standard deviation, and 5-number summary. Now, one way that you can do this is by using a program like Excel or even Google Sheets. And so what I've already done is take all the data points from that slide and I've put them into an Excel spreadsheet. And in column A, this includes all of them. And you can see that it calculated the mean, which you can find by typing in equals average and then selecting all of your data points. We find the standard deviation by using equals stdev.p and our data points. And then I found the minimum, the quartile 1, the median, the quartile 3, the maximum. Then I subtracted Q3 minus Q1, and I found the IQR. And here I took the Q3 value, I added 1.5 times IQR, and I got 8.765. So those would be our mean, our standard deviation, and our 5-number summary. Number 2, the maximum value in this data set represents the spending for the United States. Should the per capita health spending for the United States be considered an outlier? So if we look at our table, we see that IQR times 1.5 plus Q3 would put us at 8.765. So anything above 8.765 is considered an outlier. The United States value is 9.8923. So the answer is yes. The United States per capita spending on healthcare is considered an outlier. Number 3, although outliers should not be removed without considering their cause, it is important to see how influential outliers can be for various statistics. So now they want us to do the same thing, but removing the United States value from the data set. And on this spreadsheet, I've already done that. You can see right here, I've taken that value out. I've copied over the formulas. We can see that the mean has gone down. We can see that the standard deviation has gone down. The minimum is still the same. The Q1 is slightly lower. The median is slightly lower. Q3 is slightly lower. And our maximum is now lower because we've taken out that high value for the United States. We recalculate the IQR, and it is a little bit smaller, multiply it by 1.5, and add it to the Q3, and we see that that has now gone down to 8.62. Now we don't have any outliers when we remove the United States. So they want to know in part B, how do the mean, standard deviation, median, and interquartile range of the data set with the outlier removed compare to the same statistics of the original data set? And we can see every single one of them went down other than the minimum, which stayed the same. All the other values went down at least some. We notice that the mean went down by 0.19, while the median only went down by 0.09. So we can see removing the outlier actually changed the mean more than it did the median. If you're on Kidam, there is an applet that you can use to find all of these. It's built in just kind of like an Excel spreadsheet is, and you can go in there and play around and try to calculate these yourself and see how they change. So when we're investigating, they ask, do you think that 9.8923 should be eliminated from the data set? Why or why not? So the rule is we want to identify outliers, but we only want to remove them if there was an error, if a wrong number was written down, if a wrong calculation was made, if it was collected in some kind of faulty way. In this case, there's no error. It just happens to be an outlier. The United States spends a lot more per person on health care than the other 33 countries. but there is no outlier. So no, there's no error. Okay, we would only remove it if there was an error. Which measure of center is more greatly affected by the inclusion of extreme values, the mean or the median? Well, if we go back and look, our mean changed by 0.19. While our median if we look, went from 3.58 to 3.49. That's only a change of 0.09. So we can clearly see the mean was changed more by the removal of the extreme value. Which measure of variability is more greatly affected by the inclusion of extreme values, the standard deviation, or the interquartile range? So we have the standard deviation, and we have the IQR. If we go in and look, standard deviation changed by 0.34. And if we look at the IQR, it only changed by 0.05. So we can see the outlier being removed or included changes the mean more than it does the median. And in turn, it affects the standard deviation more than it does the interquartile range. So this is why we use mean and standard deviation with symmetric data, but we use median and IQR with non-symmetric data. So now we can look at our next activity. This one is titled Origins of Outliers. It says the summary or the number of property crimes, such as theft, reported is collected for 50 colleges in California, and some summary statistics are given. So they give us the mean and the 5-number summary, so we don't have to calculate those. An outlier, I'm going to calculate my IQR, which is Q3, which is 260, minus Q1, which is 52. That's 208. Now we're going to multiply 208 times 1.5, and that is going to be 312. So anything above Q3 plus 312 is going to be an outlier, and anything below 52 minus 312 is going to be an outlier. So we don't have to check on the low end because the minimum is 15. If I subtract 312, I'm going to be in negative numbers, and I can't have negative reports. So there's no outliers to the low end. But what I can do is take my Q3, which is 260. I can add the 312, which is my IQR times 1.5. and that's 572. So anything above 572 is going to be considered an outlier. And in this case, we have three values that would be considered outliers: 593, 699, and 768. Those three values would all be considered outliers. Part B, if there are any outliers, why do you think they might exist? Should they be included in an analysis of the data? So in this case, we're talking about property crimes for 50 colleges in California. If I was trying to figure out why we had outliers, I would assume that those colleges would be located in much higher population areas. So maybe Los Angeles, San Diego, San Francisco, something like that. We only want to remove outliers if we know for a fact there was an error in their collection or their calculation. So, should they be included? Yes, they should. We do not know that they were collected by error. They are probably just much higher populated colleges than the other smaller numbers. Number two, the situations described here each have an outlier. For each situation, how would you determine if it is appropriate to keep or remove the outlier when analyzing the data? Discuss your reasoning with your partner. So part A, a number Q has sides labeled 1 through 6. After rolling 15 times, Tyler records his data, and we can see the data points here. If we're looking at it, our outlier appears to be the number 20. Now, if a number cube has sides labeled 1 through 6, then there is no possible way to roll a 20. So this one would be removed because there is an error. They might have meant to put 2 instead of 20, but there is no possible way they could have rolled a 6-sided die that is labeled 1 through 6 and roll a 20. Or maybe they added multiple rolls together, which isn't what they were doing. But either way, there is an error in the collection, and we would remove that outlier. For part B, the dot plot represents the distribution of the number of siblings reported by a group of 20 people. And we see we have an outlier down here at 12. It is possible for somebody to have 12 siblings. It doesn't happen that often, but it is possible. We have no indication that there was an error in the collection. So in this case, we would leave that outlier. We just might report the data with and without the outlier included so that we can demonstrate how big a change it does make. Part C in a science class, 12 groups of students are synthesizing biodiesel. At the end of the experiment, each group recorded the mass in grams of the biodiesel they synthesized. The masses of biodiesel are given. So if we were looking at this one, our outlier is going to be 0. This would mean that somebody was not successful in synthesizing any biodiesel. So if there was an error in their experiment, we could remove it. But if they were just unable to complete, then we might not. So in this situation, we would need a little more information on why this group of students did not synthesize any biodiesel. So now the questions, why is it important to analyze the source of outliers? We need to analyze the source because if it is a valid result, we keep the outlier in and we just mark it as an outlier. If the source of the outlier is an error in collection or an error in calculation, then we go ahead and remove that outlier and calculate with the correct results. What are reasons to keep an outlier in a data set? As long as that was collected correctly and calculated correctly, we will keep it in the data set because we want accurate representation of what the data actually said. What are reasons to remove an outlier from a data set? Only if there is an error in collection or an error in calculation. If you know you have an incorrect data point, then you want to remove it because you don't want your data to be altered by an incorrect data point. What can be done about the 3 outliers for the college crime data to account for school size as the source of the outliers? You could change your collection from total number of incidents to a per capita collection. So you want it to be proportional. So now I would start calculating the ratio of crimes to the number of students on campus and then report that data, and we should see the elimination of outliers. How do you know a value is an outlier? A value is an outlier if it is more than the IQR times 1.5. If it is more than that above Q3, it is an outlier. If it is more than that below Q1, then that is also an outlier. So you need to find the IQR, which is Q3 minus Q1, multiply your IQR by 1.5, then you add that value to Q3, and you see if anything comes out above that limit, and then you subtract that value from Q1, and you see if any values are below that limit. So our lesson synthesis, what is an outlier? An outlier is any value that falls more than the IQR times 1.5 above Q3, or if it falls any farther below the IQR times 1.5 below Q1. Why are outliers important to notice in a data set? First, you need to understand whether they are there by accident and need to be removed, or whether they are legitimate outliers that you need to leave in there, in which case you need to show through your graph that there is an outlier, or you need to mention in your writing that there is an outlier. How do outliers affect measures of center? Outliers affect the mean much more than they do the median, and they will pull the mean towards the outlier. So if the outlier is to the high side, it will pull the mean up and make it bigger than the median. If the outlier is to the low side, it will pull the mean down and make the mean less than the median. How do outliers affect measures of variability? They are going to affect the standard deviation and the MAD much more than they are the interquartile range or the IQR. Why would you eliminate an outlier? You would only eliminate an outlier in the case of faulty collection or faulty calculation. If the outlier is an error, you would eliminate it. If it is a legitimate data point, you leave it in and calculate. So our cool down is titled Expecting Outlier. It says a group of 20 students are asked to report the number of pets they keep in their house, and the results are given. They give you the mean, the standard deviation, the Q1, the median, and the Q3. Number 1, would any of these values be considered outliers? And you need to explain why they are or are not. Number two, after being told they should not count any fish in the report, the value of 3 becomes a 2, and the value of 21 becomes 1. Would these changes affect the median, mean, standard deviation, or interquartile range? And if so, would each measure decrease or increase from their original value? So you're going to have to explain how, if at all, those change. Now our glossary terms: outliers, a data value that is unusual in that it differs quite a bit from the other values in the data set. In the box plot shown, the minimum 0 and the maximum 44 are both outliers. Standard deviation, a measure of the variability or spread of a distribution, calculated by a method similar to the method for calculating the MAD, or mean absolute deviation. The exact method is studied in more advanced courses. Now, we went over this in class, how you would calculate a standard deviation. And finally, statistic, a quantity that is calculated from sample data such as mean, median, or MAD, mean absolute deviation. So if you were in class today, thank you for your participation. If you were absent, thank you for coming online to see what we talked about so that you're still up to speed with your class. And if you just went back to review for the test, thank you for taking the time. And I will see you next class.